Hello, I'm Paul Rutter and I'm Project Officer with the Ancients for the Future. And we've been involved with this work for the last 3 years, and I'd like to go through the aging process of trees, as it's something which very often gets overlooked and perhaps isn't well understood. But if we're going to have our ancient trees in our landscape for the future, then we've really got to understand what's going on in and around that tree for a very long time. Tree time, as we describe it, extends well beyond the life of humans and animals, generation beyond generation. So those changes in the tree are very often not always seen. Trees respond very slowly to changes in the surrounding environment, and it occurs from time to time, around them, under them, and over them. And the trees can suffer from stress caused by these changes, and that foreshortens life or makes it vulnerable to disease. Trees are chemical factories, very complex, something we don't really even understand very well at the moment, but we do know that they're controlled by hormones and by the external changes of the environment around the tree. And human intervention can both shorten and lengthen the potential lifespan of a tree. So a tree timeline, for example, we look at the oak tree, which is our native oak and part of our landscape for many, many generations. It can live over 800 years, and it's reckoned to take around about 300 years to grow to maturity, and then it stops growing any larger, but it continues to rest and put on incremental growth around its trunk. And it will then, about 150 to 200 years, slowly die, and eventually, in the end, will return into the soil. So it recycles itself. Beech trees will go on for perhaps 400 years plus, and pollarding does extend that length. Ash trees the same, 300 years plus. Hawthorn trees can go on for 250 years probably. Lime trees 300 years, and at Westernbird Arboretum there's a coppice tree which is reckoned to be about 2,000 years old. At the other end of the scale there are birch trees and willow trees which have a different strategy, so don't live quite as long, but nevertheless still play an important part in decaying wood and habitat. Then the sweet chestnuts are 800 years old plus, and field maple can go on for many years, 200 years. And they're quite an important tree that we need to manage and include in our landscape. So ancient and veteran trees are very much under threat. We have the largest population probably in Europe because of the land use history, but they are suffering from mismanagement and lack of understanding about what and how they need in order to grow. But as they get older, they become even more biodiverse. The tree biology and the gravity, wind influences all have an effect on the survival of a tree and whether it suffers damage. The high canopy trees that grow very close together have a very thin root system, a narrow system, and a canopy that's often restricted, and they can very often be blown over because of the high centre of gravity, in comparison to those trees that have an architecture of a low canopy. There's a tree on the right here, a big old oak, possibly been pollarded over many centuries, and it's assumed this very low stem with very many low branches growing off in all directions. Other trees, some that fall over, they can't fall over twice, so they just keep growing, especially if the root plate is well established and intact despite it collapsing. And these trees can go on for centuries, sometimes called phoenix trees. And that again indicates that trees are happy to grow horizontally as opposed to vertically. So the key factors for an optimum life tree is it needs space and the light for the tree to grow a good, rich, healthy canopy of leaves. That canopy ideally needs to be low to the ground and has an extensive root system going out well beyond the canopy. This improves the balance of the tree, gives it greater stability. and it's all achieved by allowing the branches to grow laterally and outwards so that their tree becomes well balanced. And a healthy, vigorous tree, although it may lose its branch from time to time, if it's a healthy, vigorous tree, it can and will regrow new branches. And as the tree gets much older, the stem gradually hollows out, and this again improves the stability against high winds. And this was well illustrated during the 1987 storms, when many ancient trees were left standing while tall plantation trees fell over. So when branches are removed, the tree will respond, that it will regrow, because the hormones in the tree tells it actually needs the canopy to continue to grow. And in some situations where we cut limbs off, the plant responds very quickly with new buds. And in other situations, if a branch is ripped off in the wind, it leaves a broken, ragged edge, but those are very important for many saproxylic insects that seem to prefer that type of wound injury as opposed to the flush cutting using saws. But we've exploited the fact that trees will respond by being cut, and over many centuries we've pollarded trees, ash trees, oak trees, even beech trees, and they will respond if they're vigorous and they're cut at the right time and they adapt to this type of management, and they gradually decay from the centre while continuing to grow well and vigorously year on year, and the centre of the tree, as it becomes hollow, becomes a very, very rich and specialised habitat for many insects and fungi. And the pollarding of oaks has been done in part of this project in order to try to fill the gap, the generational gap that we have of ancient trees. And during the World War, many trees were felled, and we haven't got that new cohort of maturing trees becoming decayed and then turning into veteran trees. So some work's been done in order to retain the canopy. Some of the tree has been pollarded in order to respond well, and then we have a tree which is then developing with decay slowly at an earlier stage than it would if this work wasn't carried out. And veteranizing trees is being carried out across the country at different sites, including removing parts of the stem and allowing decay to enter the tree, but also creating cavities for bats, insects and birds. As the tree does develop, despite it losing limbs, and if it's been pollarded, which actually puts the time clock back to 0, the tree then resprouts and regrows for another generation. And over that time, the centre of the tree can decay, but there's a life in those trees because the fungi attack the tree, they create the cavities, and then they're followed in by the invertebrates, and then later the birds and even mammals. The bark of the tree also becomes suitable as the tree becomes older for lichen that need that type of special chemistry that's on the bark and have a well lit situation. The fungi that attacks the tree will act in different ways depending on what the actual species of fungi is. And we get brown rot and white rot. The white rot fungi, very widespread and large numbers, will actually attack the whole tree and be able to decay most of the wood eventually. Whereas we have brown rot fungi, a bit more specialised, which attack the lignin, the centre of the tree, creating cavities in the middle of the tree, eating out the heartwood while leaving the sapwood and the springwood alone, which enables the tree to continue to grow for many generations, becoming more hollow over time and creating very valuable habitat. And these are the species of fungi that will do this work. The fungi we've got are beefsteak fungi on the right, the chicken of the woods, and the very much rarer and one of our focus priority species is the oak polypore, all feeding on heartwood. As the tree does become older, it gradually changes its shape. It goes into a strategy to make it lower and wider. So the top of the canopy dies back as it becomes less efficient in being able to photosynthesize to the top of the tree. And it loses a canopy at the top, but then grows a lower canopy. but that again depends only if it has the right and efficient or effective branch scaffolding at the bottom of the tree. But the tree will evolve over probably a century or two. It takes very, very long time for this to happen, so we're not really aware of it. And the tree will eventually continue to grow despite it decaying and eventually turning into its own soil. But the biodiversity in the tree does increase over this time, and this is when the fungi, lichen, the birds and the bats find these old trees extremely valuable habitat, which again is a reason why we need to be supporting them, as well as the many thousands, or 2,000 probably, saproxylic insects that live inside or rely on decaying on dead wood. So every part of that tree is a niche to an insect of some form, or a bird, or a plant. And those niches become more valuable the older they become. The corkier the bark, the thicker the bark, and the more attractive they are to these species. So you finish up with the lichen growing on the bark. You'll find the woodpeckers inside the tree in creating cavities or using old rotting cavities, and then insects living on and around and inside the tree. Much of the English landscape was what we describe as pasture woodland or wood pasture, and this had been formed because of the land use based on herbivores grazing it, and the oak trees being able to grow through the thorn and the thickets and then gradually become mature open grown trees. And this is very much the landscape that we need to try to encourage more of, because this is where these specialist insects and species, bats and lichen, find attractive to live. Old orchards are also a very important pasture woodland, and we overlook this very often. We've lost many orchards over the last 50 to 60 years, but nevertheless the ones that are surviving have some really old trees with lots of veteran features on them, old and decayed cavities, and that's because of their management, the fact they've been pruned quite regularly. The decay enters the centre of the tree, but the tree continues to grow, and very often they'll be growing as low-growing trees in order to be able to gather the fruit easily. And then underneath the grass, it's a permanent grassland. It's not cultivated and it's not overgrazed, so it's an ideal environment for many of these species to find attractive. So the pasture woodland have many components which sadly we are losing across the wider landscape, but it's important that we do try to rebuild them back into the broader landscape rather than just in little pockets, because these insects and birds need to be able to travel and colonize and then eventually cover the whole country. And those vital components include dead and decaying wood of all sizes, standing and fallen dead wood, permanent pasture, grazing, and nectar plants, and that includes hawthorn and many of the umbellivers. They are the plants that are in flower just at the time when they're the insects that many insects that come out of the tree are actually looking for food, and the nectar is what it needs. We also need to bear in mind that these old ancient parklands, wood pastures and commons are very stable, undisturbed places, and that again is important for wildlife, where the disturbance is minimal. Change doesn't happen very quickly. The trees obviously are well suited to that. The soils are not affected in any way, and people also find these places attractive places to be. In fact, we know all too well this year how important it is for green space to be part of our DNA, that we need to get outside, enjoy good, clean, open air, and enjoy the countryside. There are many threats to the ancient woodlands that we have. Ancient trees are continuing to be removed or replaced or tidied up, and short-term tree cover is replacing them for forestry and timber production. And we think there must be room for both, because we do need to have both types of timber and types of tree in our landscape. Lack of space within the plantations will stop any mature ancient tree developing. So we need to give them plenty of space as well as grow timber. The interventions that we make will very often affect the tree negatively, and just by tidying up limbs and raising the canopy, will be the death knell to an ancient tree. It will foreshorten its life because it can't grow that low scaffolding as it becomes a retrenching tree. So eventually those branches at the top die back and the tree can no longer replace that canopy. So it meets an early end, or it may be felled. And on the right hand side, the trees that have dense canopy shaded will stop the tree from growing, and again they can die simply by lack of light. Soil compaction is a major problem, and cultivation around trees affecting the roots, while waterlogging is another problem that we're arising because of intensification of use by soil degradation and the heavier rains that we are now starting to experience more. So the tree hasn't changed in the time that we've seen these changes go on, but it's now suffering from a changing environment and the changing soil structure. So all those factors are putting a negative impact on these ancient trees. We've really got to allow nature to follow its own route, to give space for nature to do what it wants to do, because that's what all the things that live in and around the tree need. It takes time, tree time, and it takes the space for these things to be left alone to gradually decay. So thank you for that. Hello, it's Paul Rutter here again, and I'd like now to just talk to you about the benefits of fungi, which I mentioned a bit earlier, and the fact that we've often overlooked the fact that these organisms are incredibly important to the way the planet works and probably to our long-term survival and well-being. So the benefits of fungi are that they remove dead material from the environment. They are detritivores and they will absorb the dead material that is always happening every single year. And without fungi, the planet would be covered with literally meters of dead material, and that could be woody material, it could be rotting carcasses. Fungi are both habitat and food source to many insects. So again, as they go through their life cycle, they provide yet more opportunities for other species to survive and thrive. Many of them microscopic, so we're very unaware of it. Fungi are building blocks of the new soil. They will gradually break down what otherwise would be material that cannot be broken down by other organisms. Some insects can't actually eat them and animals can't eat them. So this was where the fungi come in, and they break the material down into a soil brown material. And they support and sustain healthy plant life, including trees, because the relationship that many fungi have with those trees gives the tree more resilience and able to survive events such as drought, but also get nutrients through these very specialized fungi. And they will help to increase the resilience of the tree to diseases. Fungi can also digest substances that no other organism can, and these include hydrocarbons, radioactive material, and even plastics. So the kingdom of fungi, as they are described, is neither a plant nor an animal. It relies on oxygen. Fungi are in a class of their own, and over 2 million species have been recorded so far, and there are many more yet to be found. They're found all over the planet, both on land and in the oceans, and once considered to be a threat, we now believe many of them play a vital role in our ecosystems and do more good than harm. They're divided into 4 main types, and the main one that we're particularly interested in regarding ancient trees are Basidiomycetes. If we continue to explore the natural world and continue to find the number of fungi which we have so far, we can expect that there will be another couple of centuries before we are able to identify all of them. So there's a lot of things out there that we haven't discovered, or we don't understand how they work and what their qualities are. So we really got to make sure we don't lose them, because they could be very, very useful to us. And in order to recognise that, there's an international red data list which has been set up in order to try to record as many species as possible and to try to ensure that their habitat is maintained. So the Basidiomycetes family in fungi are in mushrooms, puffballs, stinkhorn, bracket fungi, many other polypores, jelly fungi, boletus, and many others that you may just come across from time to time as you walk through the woodlands or across pasture. And part of those, or rather many of those fungi play a vital part in the management of soil and trees. 90% of them have mycorrhiza connections to plants, and these enable the plant to be able to obtain water and minerals far beyond its natural root network. And they do this by connecting to the roots and then the mycelium spreading out much further away from the tree. The fairy rings that you can see in the fields and sometimes in the woodlands are these mycorrhiza, and this is how they grow. These fruiting bodies come out of the ground, but within that and in the center of the circle will be millions of hyphae that are actually moving the material in and around the soil. Other fungi in the soil produce a sticky material called glomalin, and this helps to glue together the molecules of the soil, and they help to build up the dead organic material and the humus, which is then fed upon and used by many other species. The vital connection has created a wood-wide web, so the trees are not in isolation. Because they can't move, it doesn't mean that they haven't adapted a way of obtaining all the nutrients they need. And we're understanding more and more now just how much that wood-wide web exists and how important it is for the health of both trees and many plants. And if you could see it, well, it's microscopic, it will be something like this. Under the ground there will be a network of hyphae all disappearing off into many yards away from the tree, perhaps even miles, and feeding it back to the tree to give it nutrients. Lichen are a very important part of the mix, and they are a type of fungi, but they're also part algae. They have a symbiotic relationship in order that they're able to survive, and they can survive very extreme conditions. But they are also demanding. Some species are very rare because they need the special type of bark surface that ancient trees offer. But that bark and that habitat only occurs on trees probably over 200 years old. Many lichen contain chemicals that are beneficial to both man and animals. In fact, many animals eat lichen because of the nutrients that are within them. And we've used them for dyeing clothes and for producing fragrances, but also they have antibacterial properties. And there's a material, arsenic acid, is used in cosmetic and toothpaste and the production of deodorants. So they do have a very great use for us. So looking at wood and what it is and how it rots, we had to break it down into the three main parts, which are mostly cellulose, hemicellulose, and the smaller part is 18 to 35% is lignin, which is a very hard, indigestible material. They're high in carbohydrates but low in nitrogen. So as the tree is broken down by fungi, the fungi produces extracellular enzymes, and they absorb the material outside of the actual fungi before actually consuming it. And some of these enzymes have to be more numerous, and they're produced by certain fungi and not others, in order to break down some of those elements. And that includes lignin, which requires 12 enzymes, and it takes the longest to break down. So as the bark is initially damaged in some way, that's when allowing microbes and microspores to get into the tree. And the first line of defense that the tree makes is it produces resins, gums, and sticky material to try to breach the damage, the injury, and that prevents insects and fungal spores from entering. But if that doesn't succeed, then the trees that cannot then heal start to allow the rotting process to develop. Structural decay occurs for two main groups of fungi, as I mentioned earlier, the white rot and the brown rot. But the white rot will consume most of the tree eventually, while the brown rot will only attack the middle of the tree. And this is a decay that you'll see in brown rot. While the tree very often continues to grow upwards, it might be very damaged in the stem, but there's probably one or two branches still alive and the tree is still standing. And while it's standing, it really gives a very, very important habitat. And as the tree does become older and it can continue to grow, then it becomes wider and wider. And although the tree on the right-hand side, half of it is dead, it is still thriving. So the red rot species are the ones that produce cube rot, and the species that we're interested in are the fungi called chicken of the woods on the left, the beefsteak on the right, and the more and rarer species which we're trying to find out more is the oak polypore, and all of these feed on the heartwood. So just because the tree may have fungi on and around it doesn't always mean it's going to be dead very soon or that it's about to die. A big-bellied oak at Savonet's a good example, well over 800 years old. It's hollow, it's got many fungi on it, but it's just still growing very well and produces plenty of leaves every year. The standing dead trees are an important habitat even though they're dead, and we do need to make sure that they are part of the component in our landscape. In order to help this process and to try to shorten the generational gap, Ancients for the Future project has been helped by Cardiff University to inoculate Hericium erinaceum, a fungi to promote early heartwood decay, and that will hopefully start hollowing out these beech trees sooner than it would normally have occurred and start creating the habitat that is created by these types of fungi. We've also spent time looking for these priority species in order to try to record where they are and if trees have them, and we have been able to be successful in finding some of the oak polypore in Savonet forest, and we believe this was the first record of this particular fungi, growing on the heartwood, but it's doing the job of breaking it down slowly and creating cavities. And it's interesting that our bat survey identified barberstool bats in the vicinity of this tree that had this fungus on it. So the compartmentalization process of the tree goes on for as long as the tree is vigorous enough to respond to damage, and it doesn't mean the tree will be short-lived. It can continue to grow in a very poor state of condition with either exposed stem or just a hollow stem. There are, however, some fungi, honey fungus and giant polypore, such as this one here, which will attack the roots and eventually kill the tree. So we do need to be wary that those particular fungi do need to be identified and ensure that the tree that being affected doesn't become a liability. So in some situations that management might have to reduce the height of the tree to take the potential dangers away from it falling. But by keeping the white rot trees in the landscape are as important as keeping brown rot trees. Over time, the tree does decay slowly. The soil is produced through that decaying carbon that has been broken down, turns it into a rich brown soil, which is characteristic of old ancient woodlands. And again, is something which we need to just give time to happen, and disturbance will affect that. So I suggest that we don't ever give up on a tree, no matter how crusty it might look and how much the canopy might have been lost. If it's still producing living tissue with leaves, then it's going to be a very valuable habitat for many, many years to come and probably beyond our lifetime. And it should be borne in mind that 6% of British invertebrates are species that rely on deadwood. Threats to the fungi across the nation and beyond are very similar and might sound familiar to what I've said earlier, and that includes the removal of dead and decaying wood of all sizes, from fungicide and fertilizers, chemical fertilizers, from cultivation, ploughing and compaction will all cause root damage. And of course waterlogging of the soil is a death knell to many mycorrhiza fungi. So best practice is try to avoid these elements occurring around any ancient trees or any recruit ancient trees.